Yeah, I think problem 2 is also kind of a mouthful to read. Yeah, okay. Okay. Yeah. Um, yeah, so there's like this weird rule for like determining contestants, right? So yeah, so like I think the way I like visualized this when I was reading the problem statement was like some kind of table where these are the criteria. So this is like uh yeah, so I'll just write criteria and then let's just label them 1 to C. And then these are the ranks. Let's label them 1, 2, all the way up to N, right? And then some of these cells they're like filled if there's a person that meets that criteria, right? Something like this. Yeah, and then basically the selection is you take the top F1 students from the first criteria. Um, so I'll just like highlight them in red. Maybe we also highlight this. Um, and then among those that weren't chosen, you take the top F2 students from the second criteria. Yeah, I'll just highlight the taken ones in red. Right? So it's always going to be a prefix of it, whatever, right? Yeah, something like this. And then you take the top F3 students, right? Yeah. So I think like, yeah, one observation to make is, wait, let me just make sure. Okay, yeah. So let's like fix a person. Let's fix a person I. Let me just draw it to the side. Let's draw another table. Yeah, okay, yeah. So the problem statement is like you're given a permutation of people who are like deleted, and then you want to find like maintain the sum of the ranks when people are deleted, right? Yeah. So I think like one observation to make. So if this is a table, this is rank. Let's say this rank equal to I, right? And these are all the criteria for the person with rank equal to I, right? So one observation you can make is if this one is selected, right? Um, then these are never going to be selected, right? Because you'll always pick this criteria, like this prefix is always going to grow more and more, right? So you're always going to pick this criteria over these, right? So you're always going to pick this person for this criteria instead of picking them for this criteria. So if you ever are in the situation where you pick some person of a particular rank for a particular criteria, then you can kind of like remove these, right? So that's kind of going to be our algorithm, right? So we assign people, like we assign ranks to the criteria, and then we keep removing the ones that are below, right? Yeah, so I'll just draw a third copy, I'm drawing a lot of copies. Um, yeah, so this is the rank, and this is the criteria. Um, And then like you can think of these black cells as candidates, and we kind of remove these candidates because this one was selected, right? And then basically like for each criteria, some prefix of the candidates, like some prefix is the ranks, you can consider it to be active. And then some suffix of the ranks, you can consider it to be inactive, right? Yeah, so you can like kind of visualize this for all the rows. Um, yeah, yeah, maybe it'll be something like this. Yeah. And then I'll just like draw this to the right because we know that like if something is active here, then we already like ruled out the inactive ones here, right? So you can kind of visualize like each row or each criterion, like some prefix of the candidates are active, and then some prefix of the candidates, suffix of the candidates are inactive, right? So you can kind of like initialize this and have a sum. And then when you remove the ith person, let's say we remove the ith person. So this is person I, uh, yeah, let's just say there's also like some active ones here, whatever. Um, yeah. So basically, when we remove the ith person, let's say the ith person is active for the first criterion, then we can kind of just like remove this, and then we extend this forward, right? Um, yeah. And yeah, so we're going to remove everything for the ith criterion, and then we're going to extend this forward. And when we extend this forward, basically, like if there's anything below, since this is active, and since we already argued earlier, if something is active over here and the things below are inactive, then you can kind of delete them, right? And yeah, and maybe it's also possible that something here was already active earlier, and since this active has been transferred to here, then we have to like delete this, and then maybe now this one will become active, right? So it's going to create some kind of chain reaction. Like when we extend, like when we remove the ith person and we extend it, it's going to create like some kind of chain reaction, right? Yeah, so that's like the high level for how you can like think of this problem. Yeah, so I think the data structures I used is like for each row, just like maintain a set of actives. So active just means it's like it's been invited to the contest, right? And we know it forms a prefix, and then a set of inactives for that criteria. So this is like a set of all the ranks. And then for each column, we just store like the set of candidate criteria, right? Yeah. So this is how you do that problem. Any questions? Yeah, my implementation's a bit chopped, but I might also show that. Yeah, this problem was pretty cursed. Yeah, and I think, yeah, there are like some details in like the actual implementation, right? Um, yeah, so you need to like, uh, yeah, so when you're removing the ith person, like it's gonna be active in some criterion. So you need to like update, yeah, like if you remove something where it's active, then you need to like update that criterion, and then also like remove the things below that active thing. And it's going to create a chain reaction. Yeah. Yeah, I'll share my implementation. Uh, yeah. If I still have it. Yeah, I should still have it. Okay, let me open it up. Okay. Um, okay, let me just give me a second. So this was problem 2. Yeah. Okay. Yeah. Yeah, hopefully this implementation might give like a slightly better idea of how this works. Uh, okay, let me share. Yeah. Yeah. So basically I have 3 vectors of sets I can just draw to the side. Um, yeah. So like this has length n, and then this has length c. And basically, yeah, I store a set of the actives for every column. So these are the actives for every column, and then these are the inactives for every column, right? Yeah. And then I also store for each rank, like which candidates I should consider, right? So I can imagine I have like these vertical things, right? Yeah. Um, and then there's just like pre-processing the input. Yeah, I just put these things into functions just so that it's like a bit cleaner, right? Yeah. So basically, yeah, just like we can think of this as a black box now, first, but these are the people you remove. And then basically like we iterate over all the candidates for that particular rank. Um, yeah, and then yeah, so I also maintain some set that tells like which criterion I should actually update. Yeah, so if this criterion is like an active person, then we also need to update that criterion, because if we remove someone who's active, like let's say we remove this guy, sorry, my 10. Yeah, so let's say we remove this guy, then that means we have to extend this active thing, right? Um, yeah. Um, and then otherwise, like we don't really have to, like if we remove someone who's inactive, then we don't really need to change anything, right? Yeah. And then I have this function called make changes. Basically, like to update is the criteria I need to update. So yeah, basically this is kind of simulates the chain reaction, right? So to update, like we consider the topmost criteria that we actually need to update. Um, yeah, and then like basically in the current criterion, we just like keep extending this active segment. Um, and like yeah, we just keep extending this active segment, like replace some inactive things. And when we make this active, it's gonna create a chain reaction below, right? Yeah, so basically, yeah, you can loop over things below, and then you can simulate the chain reaction, right? So if the thing below was already active, then you need to update like this active row also. If it's not active, then you don't have to update that row. Yeah, but that's the idea for this problem. Any questions? Yeah, so I think the idea, like the observations are kind of simple. Like I guess the main observation is like if someone uh yeah, if someone is active, then you like disregard the ones that are below. I think the hardest part of this problem is like yeah, actually spending time to think about the actual details of how to implement. Yeah. I think yeah, this probably took was the most time consuming part of the contest for me. Okay, let me change my screen share back. Yeah, I did try the gold contest, and I think that also had like some really uh yeah, cursed implementation. Yeah, I don't think I've looked at the subtasks. I think I did, but yeah, so I think yeah, there are some subtasks which are kind of free. Like this is where there's one criterion, so you can just simulate with a set. Yeah, and then this is where criteria equal to 2. I guess it might be slightly easier to implement because like there's not really a chain reaction. There's only like 2 criteria we actually care about. Yeah, and probably this one is brute force. So I think yeah, if you don't like full solve this problem, you can probably get like most of the points. Yeah. Um, yeah. So I think like yeah, full solving 1 and then full solving 3 and then partial on 2 should also be enough to pass.